It is not permissible to transition from Greenfield, also known as Flexible Metal Conduit, to Liquidtight, also known as Liquidtight Flexible Metal Conduit, in the middle of a run without using a junction box. The reason for this lies in the grounding requirements of electrical systems. Greenfield, being a metallic conduit, provides a continuous ground path when properly installed. This ground path is crucial for safety, as it allows fault current to flow back to the source, tripping a circuit breaker or ground fault circuit interrupter, and preventing electrical shock hazards. Liquidtight Flexible Metal Conduit, or LFMC, on the other hand, only provides a grounding path if it is metallic. Non-metallic liquidtight conduit does not provide a grounding path. If you were to transition from Greenfield, which inherently provides a ground, to a non-metallic liquidtight conduit without a junction box, you would be interrupting the continuous ground path. This is a violation of electrical codes and creates a safety hazard. The purpose of a junction box in this scenario is twofold. Firstly, it provides a code-compliant transition point between the two different types of conduit. Secondly, and perhaps more importantly, it allows for the installation of a grounding conductor within the box. This grounding conductor ensures that the ground path remains continuous even when transitioning to a non-metallic conduit. The grounding conductor is typically connected to a grounding terminal within the junction box, and then extended to the equipment being served by the circuit. This ensures that the equipment is properly grounded, regardless of the type of conduit used for the run. Now, let's delve deeper into the requirements for using LFMC for grounding purposes. According to the National Electrical Code, or NEC, metallic LFMC can be used as an equipment grounding conductor under specific conditions. These conditions are outlined in NEC section 250.118. Firstly, the LFMC must be listed and marked as suitable for grounding. This means that the conduit has been tested and certified by a recognized testing laboratory such as Underwriters Laboratories, or to meet the requirements for grounding. Secondly, the combined length of flexible metal conduit and flexible metallic tubing, or FMT, in the ground return path must not exceed 6 feet. This limitation is in place to ensure that the impedance of the ground path remains low enough to effectively carry fault current. Thirdly, the circuit conductors must be protected by overcurrent devices rated at 20 amps or less for 3/8 inch through 1/2 inch trade sizes, and 60 amps or less for 3/4 inch through 1/4 inch trade sizes. This requirement is related to the ampacity of the LFMC and its ability to safely carry fault current. Finally, fittings must be listed for grounding. This means that the fittings used to connect the LFMC to the junction box or equipment enclosure must be specifically designed and tested for grounding purposes. These fittings typically have a low impedance connection to the conduit and provide a reliable path for fault current. It's important to note that even if metallic LFMC meets all of these requirements, it is still generally recommended to install a separate equipment grounding conductor within the conduit. This provides a redundant ground path and further enhances safety. The equipment grounding conductor should be sized according to NEC Table 250.122, based on the rating of the overcurrent device protecting the circuit. In summary, you cannot transition from Greenfield to non-metallic liquidtight conduit without a junction box because it would interrupt the continuous ground path. If you are using metallic LFMC and want to rely on it for grounding, you must ensure that it meets all of the requirements outlined in NEC section 250.118, including being listed for grounding, limiting the combined length of flexible metal conduits, using appropriately sized overcurrent protection, and using listed grounding fittings. However, it is always best practice to install a separate equipment grounding conductor within the conduit to provide a redundant ground path and enhance safety. Always consult the latest edition of the NEC and local electrical codes for specific requirements and location, and consult with a qualified electrician if you have any questions or concerns. The code provides the minimum safe requirement. One can always exceed minimum requirements for an added level of safety and or redundancy. The importance of a continuous and reliable ground path in electrical systems cannot be overstated. It is a critical safety feature that protects against electrical shock hazards and equipment damage. By following the NEC guidelines and best practices for grounding, one can ensure that electrical systems are safe and reliable. Now consider the scenario where you have a long run of Greenfield conduit and need to make a connection to a piece of equipment that is located in a wet or damp environment. In this case, you might want to transition to Liquidtight conduit to protect the wiring from moisture. However, simply transitioning from Greenfield to Liquidtight without a junction box is not permitted, as we have discussed. Instead, you would need to install a junction box at the transition point. The Greenfield conduit would terminate in the junction box, and then a length of Liquidtight conduit would extend from the junction box to the equipment. Within the junction box, you would need to connect the equipment grounding conductor from the Greenfield conduit to a grounding terminal. You would then need to run a separate equipment grounding conductor from the grounding terminal to the equipment inside the Liquidtight conduit. This ensures that the equipment is properly grounded, even though it is connected to the Greenfield conduit via a length of Liquidtight conduit. In addition to the grounding requirements, it's also important to consider the support requirements for both Greenfield and Liquidtight conduit. Greenfield conduit must be supported at intervals not exceeding 4.5 feet, and within 12 inches of each box, fitting, or raceway termination. Liquidtight conduit must be supported at intervals not exceeding 3 feet for trade sizes 3/8 inch through 1/4 inch, and at intervals not exceeding 4.5 feet for trade sizes 1/2 inch through 4 inch. These support requirements are in place to prevent the conduit from sagging or becoming damaged, which could compromise the integrity of the wiring and create a safety hazard. When installing conduit in a wet or damp environment, it is important to use fittings that are listed for wet locations. These fittings are designed to prevent moisture from entering the conduit system and damaging the wiring. They typically have a watertight seal that prevents water from penetrating the connection point. It's also important to use conductors that are rated for wet locations. These conductors are designed to withstand moisture and are less likely to corrode or break down over time. They are typically identified by the suffix W in their type designation, such as THWN or XHHW. When pulling conductors through conduit, it is important to use a lubricant that is specifically designed for electrical applications. This lubricant helps to reduce friction and prevent damage to the conductors. It's also important to avoid overfilling the conduit with conductors. The NEC specifies the maximum number of conductors that can be installed in a given size of conduit based on the size and type of conductors. Overfilling the conduit can make it difficult to pull the conductors and can also cause overheating. The NEC provides tables to assist in determining the allowable fill for conduits. These tables take into account the size of the conduit, the size of the conductors, and the type of insulation on the conductors. When making connections to electrical equipment, it is important to use connectors that are listed for the specific type of equipment and conductor being used. These connectors are designed to provide a secure and reliable connection that will not loosen or corrode over time. It's also important to tighten the connectors to the proper torque specification. Over-tightening the connectors can damage the equipment or conductors, while under-tightening them can result in a loose connection. A torque wrench should be used to ensure that the connectors are tightened to the proper specification. When working with electrical systems, it is always important to follow safe work practices. This includes wearing appropriate personal protective equipment such as safety glasses and gloves, and energizing the circuit before working on it. It's also important to use insulated tools to prevent electrical shock. If you are not comfortable working with electrical systems, it is best to hire a qualified electrician to do the work. Electricity can be dangerous, and it is important to take all necessary precautions to prevent accidents. Firstly, always disconnect the power. Secondly, test before you touch. Thirdly, use insulated tools. Fourthly, respect clearances. Fifthly, wear appropriate personal protective equipment, or PPE. Sixthly, be aware of your surroundings. Seventhly, avoid working alone. Eighthly, follow lockout-tagout procedures. Ninthly, never bypass safety devices. Tenthly, inspect your equipment regularly. Remember, safety is paramount when working with electricity. Always follow safe work practices and consult with a qualified electrician if you have any questions or concerns. Failure to do so could result in serious injury or death. Consider these points for a safer electrical installation and working environment.